Hi, today's task is to climb up this wall. Welcome to a new Cube video. My name is Pavel Savyanko, and today I show you how do we handle tasks in CubeGUI. Let's do it.
Okay, we are back into our terminal, and in this video I would present you another feature of CubeGUI, and namely representation of OpenMP task or CUDA kernels, which are being executed asynchronously. And for that we start actually our cube. Here I have to mention that the representation which I will demonstrate now is available since our currently now upcoming release 4.8.2. So if you have a older release, representation works similarly up to the small details. If you have younger one, then it should be how I presented, or maybe it has been changed in the future. But currently, in the current release, it will be that how I want to present you. So we open a cube file like this one. That's example of a cube file where one uses OpenMP tasking paradigm to run some scenarios, some tests, basically asynchronously using tasks. And within this task or outside of this task, one launches several CUDA kernels, which will be executed on a CUDA actually device. So the first of all, one has to mention that this functionality is related or provided by the standard plugin which we deliver called 3-item marker. So if we just take a look at this plugin, 3-item marker, that is our standard installation, and it marks related items inside of the call tree, task tree, system tree, and it allows also user to mark manually the elements. How manual marking is working, I have been presenting already in another video. In this video, I only want to show you the functionality related to tasks and related to CUDA kernels. So if one has this plugin disabled, like here, it would be then checked out, then it will not work. So one has to check this menu plugins, activate or deactivate plugins, or initial activation settings, that this plugin is actually enabled. So first of all, in such case, one can see that we have in the middle pane, or where the call tree is actually displayed, additional tab, tasks. So we have next to the normal call tree also tasks, and then flat tree. So if we expand our example, so that's some test file, test example, we see that here some constructor is being executed, and the main, there is the buffer flash, and there are kernels. So let's expand the main. Then we see that there is some API calls, there are also some CUDA calls, and we see that there are also some OpenMP calls, like parallel region and called CUDA launch sites. Obviously, within this parallel region, we are going to launch some CUDA kernels, and there are some different calls are implemented, different level of nesting, and. So it is just test file. So here, what is interesting is this kernels subtree and this task subtree. So first to the task subtree. If we expand it, then we see that it's basically like a call tree, but related only to the tasks which are being executed asynchronously. So one could imagine the execution of the program as execution of independent asynchronous tasks, where main is also one of the tasks, It's just very special. It is being executed by every program. And sometimes there are more tasks are executed, and these special additional tasks are displayed not anymore in call tree, but they are in the task tree. The technical reason for that is that because they are being launched within the OpenMP parallel region, their execution time gets attributed twice, once inside of the actually task call tree, also to the OpenMP parallel region, and therefore in order to avoid this double accounting, we display it separately. So if we take a look here, we see that this OpenMP task on line 108 has launched the foo, and foo was launching some Q memory, host to device transfer. Then there is a busy kernel, so obviously that's kernel from CUDA, and then there's device to host. And another OpenMP task which was launched on line 102 is again foo, and it's doing pretty much the same thing. If we take a look at info, busy kernel is the line 1435 on CUDA launch sites, and if we take a look here, that's 1435, so it's basically the same kernels. They are being executed or launched from the very same, from different tasks. Okay, so if we take a look, click back to the call tree, we see that there is the tree has expanded, and we have here multiple selection. So what does it mean? So basically, if we click here on some element within task, the CubeGUI tries to find the launching place for this task within the call tree. So in this case, it looks for OpenMP task CUDA launch site test CU 102. And because we launch this task actually from multiple call passes, it selects them all. This also makes sure that the times which is attributed to in the system tree, for example, or here, it's basically together time aggregated. So if you take one takes a look at the task and collapses here, so one sees that this time is identical here. So that is how this selection is working between tab call tree and tab tasks. So if we select here this task, it looks for the CUDA launch test 108. We check here, and that was only one place where it has been launched. Okay, another thing, if we open here busy kernel, and we see that there is a call launch kernel. So that's the place where we have launched a special kernel which has been executed or being executed on a device itself. So we display it as additional part of the call tree under the element kernels. And we see we display here markers. So this chain element shows that this call path is related, and that is how it is displayed in tooltip. It's related to the busy kernel, which is in call tree tab. And with another marker, with this arrow, we indicate that this kernel is being displayed in another tab. That's why we mention it explicitly in a tooltip, which it will appear related item in call tree tab. So we have to change to call tree tab, and we see that the launch site is selected, is 108, but marked the element, the corresponding element is within this kernels. So for that we go with a right button on the mouse, and we go to expand and expand marked, click, and that will open the call tree so that the marked element will get visible. And we see that this element has also now marking, and it is indicating that it's related to the CUDA launch kernel with ID 101, and that is in the task tab. And this arrow shows that it is another task, and therefore, if we click here, we see this element. If we click here, we see this element. So in this way, we can establish the connection between these two elements. The same is valid for example, this kernel. So there are 3 places where we launched some CUDA kernels. So this kernel is launches a busy kernel with caller ID 12. This kernel launches the busy kernel with caller ID 84, which is also in a call tree type, and this is a place where we launched busy kernel with caller ID 105. They are actually all the same busy kernels, but being launched from separate places, we keep them separately. So if we take a look here, then we see that multiple invocation places are being selected here, and the corresponding busy kernel is marked down there in the kernel. So if we go for here, we see that it is different. It is this one. If we go for this one, we see that it is this one. So in this way, we can find in our display the actual CUDA kernel which is being executed after this Q launch kernel. Okay, but we see that here are more kernels displayed than actually this 1, 2, 3, 4. So if we just select this kernel, for example, we see that there is a chain marker, so it is related, but obviously this CUDA kernel has been launched not within some task, but outside of task, so from the place which is displayed in a very same call tree, in a call tree. And to see it, we again go with the mouse, right click, expand marked, and then we see that this kernel has been launched within OpenMP parallel 272 foo, and then here is the busy kernel and CUDA launch kernel. The same is valid for another one, so the marker jumps to another call path. If we expand it step by step, we find also the place where this kernel has been launched. Okay, so what this ID means, so if we take a look here on info, we see that the ID of this busy kernel is actually 95, and this caller ID, that is the ID of the call path which has launched this busy kernel, and this is 44. So if we click here, we see that this ID of this Q launch kernel element is 44, but it is related to the busy kernel with ID 95. That's why it is called here callee, and here is caller. Yeah, that is the relationship between these two elements. And because they are all in the same call tree, there is no arrow, there is only chain element. That is the way how we establish a link between the different elements within a call tree, and that is the way how you can understand which task was launched where and where it has been executed. So the tasks which are in a tab task, they are tasks which are executed on CPU. That's why we have to display them separately. And the kernels, these are tasks which have been executed on device, on basically GPU. That's why we display them under the kernels. I hope you understand a little bit more and better our way how to display the CUDA and OpenMP task, and that will help you in your analysis. If you have some questions, comment. If you like, press us a like, subscribe, and see you next time.